All right, ladies and gentlemen, we're going to go on Lesson 8.4, Scientific Notation. Okay, we're going to compare numbers written in scientific notation. So we need to begin with talking about what scientific notation is. This, you'll notice, is going to be done in a couple parts, so be prepared for that. So first of all, scientific notation is a method of writing very large, very small numbers using powers of 10. Okay, so for example, when we're talking in our scientific notation here, we are talking about things that are like, say, the distance between galaxies. Okay, things that are very, very large. Or the size of atoms, things that are very, very small. And we do so using powers of 10. Okay, it's to help us shorten up numbers and not have to write them to the full length, but also being able to function using them. So, first of all, we need to talk about what happens to a number when you multiply it by 10, or multiples of 10, like 100 or 1,000. And one of the common things that people try to tell me is that, well, we simply add a 0. That is incorrect. We do not add a 0. Okay, that is the elementary version of what we are actually doing. And it's half correct, but it's not completely correct. All right? The correct answer to what happens to a number when we multiply it by 10 is we move the decimal one place to the right for every 10 that is being multiplied. Okay? And yes, because of this, you may be adding a 0 or multiple zeros, depending on how many places you have to move the decimal. But it is not simply add a 0. Okay, so we have to, first of all, get away from that elementary level mentality. Okay, not to pick on it, it's a fine way for young students to learn how to deal with multiples of 10, but now we're taking it to the next level. Okay, so now, dealing with multiples of 10, and what happens when we multiply by values of 10, I have a chart here. And we're actually going to start over here on this side of the chart, and then we'll move the other way. Okay, so 10 to the first power, what does that mean? Well, that means, it's just 10. Okay, 10 squared, well, what does that mean? Well, that is 10 times 10. Okay, 10 to the third power is 10 times 10 times 10. And 10 to the fourth power is 10 times 10 times 10. I know my boxes are a little small here, times 10. Okay. Now, what is the value of 10? Well, that's just 10. What is the value of 10 times 10? Well, that is 100. And 10 times 10 times 10 is 1,000. And 10 to the fourth power is 10,000. Okay. So talking about what all those values mean helps us, because when we're multiplying by these things, well, multiplying by 10, what do I do to the decimal? Well, I move the decimal one place to the right. Okay? And if I continue that pattern, 10 to the second power, I move the decimal two places right. Okay, and 3 places, I'm going to abbreviate here, to the right. And 4 places, right. Sorry, I'm going to use an arrow, to the right. That's a very poorly written arrow. Let me fix it, because I don't like, again, it is hard to write with this mouse sometimes. Okay, but when I'm multiplying any of these things here, I'm multiplying and I'm moving the decimal a given number of places to the right. And how do I determine that? Well, one, it could be the exponent, because you'll notice here, let me get my highlighter out here again. Okay, 10 to the first power, I went one place to the right. 10 squared, I went 2 places to the right. 10 to the third, 3 places. 10 to the fourth, 4 places. Or you could go by number of zeros. 1 0, 1 place. 2 zeros, 2 places. 3 zeros, 3 places. 4 zeros, 4 places, and so on. Okay, so those are some of the shortcuts. Now let's go back the other way. fill in the rest of the table going the other way. Well, 10 to the 0 power, we've already talked about. 10 to the 0 power is 1. Okay? And if we're using our pattern here in this particular case, I obviously have to divide by 10 moving to the left. So what does it mean? Well, 10 to the 0 power is 1. Talked about that. Also, you could go 1 over, if you really wanted to, 1 over 10 to the 0 power. You're still going to end up with 1 over 1. Okay. When I multiply by 1, do I move the decimal anywhere? No. So it doesn't go anywhere, so no movement at all. All right, no right, no left, or anything. And if I continue that, those things going the other way. Sorry, I messed up here. This is a 0, which gives us 1. Okay, now I'm comfortable again. My fault. I hate it when I mess up like this. This would be 1 over 10 to the first power. But what is 1 over 10 to the first? Well, that's 1/10. Okay, and what's going to happen then to my decimal? Well, that's going to go one place left. Okay, one place to the left. 1 over 10 squared. Well, that's 1/100th, which will be 2 places left. Alright, and again, our shortcuts for those, if you notice, let me move this out of the way. 10 to the first power, 1 left. 1 0, 1 left. 10 to the second power, 2 left. 2 zeros, 2 places left. So we have those shortcuts that help us. And so what we're dealing with is dealing with these ideas of what happens when I multiply by multiples of 10. All I have to do is slide the decimal to the right and left based on the exponents. So all of that to get to that understanding. So when we're converting from scientific notation into standard notation, now this is a number in scientific notation, 4.36 times 10 to the 4th power. So what that is telling me here is I am taking this number, this 4.36, and I'm multiplying it by 10 4 times. So my decimal will go from where it starts 4 places to the right. Okay. If we're multiplying with a negative exponent, we will move the decimal 3 places to the left. Again, going back to our table, what happens when we multiply by negative exponents? We go to the left. Now, the important part of that is, once we move to the right or left, is we may have to add zeros. In this one here, you'll notice I had to add 2 zeros in order to give me my 4 places. In this particular case, you'll notice I had to add 2 zeros to get me my 3 places to the left. So we are going to add zeros if necessary, but it's not always necessary. So now, go ahead and let's multiply. We're going to convert from scientific, this is in scientific notation, into standard notation. So I'm going to multiply 4.62 times 10 4 times. So that's telling me I'm moving the decimal 4 places to the right because I am multiplying by 10 4 times. 4, 6, 2. Okay, that gets me 2 places, but I am going to have to add 2 zeros to get me the full 1, 2, 3, 4 places. So 4.62 times 10 to the 4th is 46,200. All right. 3.31 times 10 to the 7th, so the decimal has to go 7 places to the right, and I need to add the appropriate number of zeros to get there. Well, 1, 2 places gets me the decimal behind the 1, so I will need 5 additional zeros. So 3, 3, 1, and 1, 2, 3, 4, 5. So the decimal now is way down here at the end, which you don't have to put it if it's at the end. So my number now, you'll notice, is 3,310,000. And I know this number here is not written terribly smaller than, or vice versa. This is not terribly smaller than that. But when we're talking about numbers that are, say, 10 to the 20th power, those get very, very long. So, okay, 2.42 times 10 to the negative 3. The negative 3, I'm multiplying now by 1/10 3 times. So that's going to move my decimal to the left 3 times. So I got 1 there. I need 2 zeros in front. 0, 0. 2, 4, 2. And in this case, make sure that you do absolutely place your 0. All right, 10 to the negative 4 is moving my decimal 4 places left. There's 1. I'm going to need 3 more zeros. 1, 2, 3. And again, definitely placing my 0 in front and my 3, 3, 2. So there we go. Just a matter of sliding decimals left and right. So that gets us to the end of scientific notation part 1. So stop this video, and if you want to, even you can go to the assignment and work on that part of the assignment, and then come back and watch the part 2, or you can begin the part 2 video now.